This is a study of triangle inequalities. So let's look at our number routine. Alice says angle C is opposite from the longest side. Well, first of all, angle C is the smallest angle of the three, is the smallest interior angle. And from the picture, it seemed like line AB, A to B, is the smallest of the three sides. I'm going to have to respectfully disagree with her. I think she should have written on the other is across from the smallest side. If she really wanted to do it correctly, angle B is the largest interior angle. And from what I can tell, it seemed like line AC is the longest side. So the largest angle is always across from the longest side, while the shortest angle is smallest angle is across from the shortest side. So let's look at our thing. You're going to be given three lengths of a triangle. You're going to tell me, is it possible to make a triangle or not? So we are given, whoops, you're given 6 centimeters, 11 centimeters, and 15 centimeters. Let's see if this is going to make a triangle. Do, do, do. Do, 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 do. Yes, it is possible. Where's my calligraphy pen? It is possible to make a triangle. Next one. You're given 3.5, 6, and 9.5. Well, I'm going to say not possible right away. It is not possible because I don't think it would make a triangle. Next one, you are given 16, 11, and 8 centimeters. Possible or not possible? Let's click on this. There. Possible. Next one, you're given length 16, 8, and 6. Well, definitely not possible. Not long enough. So you're going to create your own. And after you create your own, you're going to try to make an observation and note. Why are some triangles possible while others are not possible? Why is 6, 11, and 15 centimeters are possible, 8, 11, 16 are possible, while the other two are not? Here's a hint. Circle the two smallest sides. These are the smallest sides. These are the smallest sides, the two smallest sides. If you find the sum of the two smaller sides, what do you get? The sum of these two smaller sides is 17. Is that greater than the third side of 15? It is. The sum of the two smaller side, 8 and 11, is 19. Is that greater than the third side, 16? Possible. But if you look at the other two, let me use a different pen color. If I circle this side and this side, that adds up to 9 and 5/10. Is that greater than 9 and 5/10? No, that is not possible. If I circle the two smaller sides, the sum is 14. Is that greater than 16? No, that's why it's not possible. So the observation I would like you to make is this. The sum of the two smaller sides is greater than the third side. So let's practice on some of these examples. So 3, 5, and 9. Will that form a triangle or not? If you take out the pieces from your angled legs, you'll see it is not possible. Mathematically, if I circle the two sides, what is the sum of that? 8. Is that greater than 9? No, that is not form a triangle. Circle the two smaller sides, 3 and 5. Is that greater than the third side? No, not possible. Circle the two smaller sides, 8. Is that greater than the third side? Yes, it is. That's why it is possible. So we're going to go through some of the examples and see which one will form a triangle and which one will not form a triangle. For this one, the two smaller sides are 1 and 3, which is the sum of 4. Is that greater than 4? No. The two smaller sides are 5 and 10. That's 15. Is that greater than the third side, 13? Yes. The two smaller sides are 5 and 13, which is 18. Is that greater than third side? No. The two smaller sides are 11 and 3, which is 14. Is that greater than third side? Yes. The two smaller sides, oh, well, they're all the same. 2 and 5 tenths, 2 and 5 is 5. Is that greater than 2 and 5 tenths? Yes. That's an equilateral triangle, by the way. The two smaller sides are 6 and 4. Is that greater than 9? Yes. The two smaller sides are 9 and 8, 8100s, and 6 and 1900. If you add those two numbers up, it adds up to 16. Is that greater than 16? No. So give an example of 3 lengths that can form a triangle. For example, if I have 10 and 12, it has to be greater than the third side. Together, that's 22, so I'll say 20. Let's do 10 and 12 again. 10 and 12 is 22, 5. But that is actually greater than 5, so that's a good one. But no, these are the two smaller sides. So 10 and 12. That's 22. So let's pick 30. Are the two smaller sides of 10 and 12 greater than the third side? No. So complete the set of lengths so they can form a triangle. So 5 and 8 are the two smaller sides. 5 and 8 is 13. Has to be greater than third side. So I'll choose 12. 1, 1 is 2. Greater than 1. 6 and 15 is 21. Greater than 20. 4 and 10 is 14. Greater than 13. Put a circle the length in each of the sets above that would have the largest angle opposite. This is the largest side, largest angle. I'm going to skip this one because they're all the same. This is the largest angle, largest side. Largest angle, largest side. Put a star in each of the sets that would have the shortest angle opposite. Shortest side, shortest side, shortest side, so shortest angle. Were there any sets that did not have a longest side or shortest side? Yes, it was this one. It is called an equilateral. It looks like this. All the sides are equal and all the angles are equal, which is 60 degrees. And let's do our last two example. The two shorter sides of a triangle measures 12 centimeters and 18 centimeters. The sum of that would be 30 centimeters. It has to be greater than the third side. So which of the following could not be the length of the long side? So 30 has to be greater than 29. 26, 31. C is not possible. And it is greater than 25. Which of the following lengths can be the sides of a triangle? So these two are the smaller. The sum is 122. Is that greater than third side? No. These are the two smaller sides, 83. Is that greater than 83? No. The two smaller sides are 30 and 16, which is 46. Is that greater than third side? Yes, H. So this is the study of triangle inequalities. In this study, the two shorter sides, the sum of it, has to be greater than the third side.